Okay, number 3, we're asked to prove that if A is similar to B, then their traces are the same. So I'm going to assume A is similar to B, and I need to show the trace of A is the trace of B. Okay, so assume A is similar to B. Once again, what's that mean? There is a matrix P so that A equals P inverse BP. Well, to get the traces involved, I'm just going to take the trace of both sides. The trace is a function, so if I have two different ways of expressing the same matrix, their traces are the same. Now at this point you might be horrified and think you have to go through the element by element description of this product to get this to work out. Well, we don't have to, because we already did a lot of work on the trace in the last checkpoint quiz. In particular, we showed this, that the trace of a product of two n by n matrices is that the trace of A times B is the same as the trace of B times A. So here's what I'm going to do. I would like to effectively get the P's out of there. And how can I get the P's out of there? Well, if I get P next to P inverse, that multiplication turns out to be the identity. So I'm just going to group this as my first factor, and then that is my second factor. And if I think of this property another way, it says if I've got the trace of the product of two factors, I can reverse the multiplication of those two factors. So I get the trace of A then is the trace of P times P inverse B. So I'm reversing the order of these two factors. Now I use my associative property, and that's P inverse B. Well, that's the identity. And the identity of B is just B. So I get that the trace of A is equal to the trace of B as required. That'll do it for checkpoint quiz 3.